So the next topic would be hardenability. Thus the property which determines the depth of the distribution hardness induced by the quenching from the austenite conditions. The hardenability is a measure of easing forming martensite. That means there is a test for Germany end quench test that we are going to use for measuring the hardness. The most adapted method of determining hardenability is Germany end quench test method. It is also universally accepted and it is relatively easy to perform. It has excellent reproducibility and it gives information useful to the designer as well as manufacturer. So now we are going to see about Germany end quench test specimen. So how kind of a specimen can be manufactured? A bar of steel to be tested is machines to give a cylindrical shape. So as per the drawing that we know that in this kind of a shape to be manufactured, which material to be tested. Then the long or length should be 1 or 2 mm like 4 inches and the diameter with an upper lip of 25.4 mm at 1 inch. So this is a test specimen that we are having. Then the Germany end quench test apparatus. So this is the Germany end quench test apparatus. So this is the specimen what we have discussed, and this is an apparatus what we are having. So in this apparatus, like there is a water sump. In that water sump, there is a pump. This pump is to compress the water and supply to the one end of this specimen. So this is then again it comes back to the water sump. So this is the apparatus what we are having. So how the Germany end quench test is to be maintained. The standard test piece is heated to the above upper critical temperature of the steel. That means the test piece is heated above the upper critical temperature. So most important parameter is upper critical temperature until it becomes completely austenite. Why we are making to the upper critical temperature? Because the structure to be maintained in the completely austenite form. For that purpose, we are making Germany end quench test. So the standard test piece is heated up to upper critical temperature. Then very quickly it is transformed to the apparatus from the furnace. And immediately we are starting the punching process at the one end. That means this is the test specimen. In this end that we are going to quench the specimen. So we are supplying the quenching medium of water. Here we are using the quenching medium is water. Thus the water is compressed with the help of a pump and the pressurized water is to be forced over the specimen at the one end of this specimen. So when we are making this, the test piece has cooled. A flat approximately zero point 0.4 mm deep is grounded along the length of the bar. Now, after completion of this cooling process, that means after completion of this punching process, now we are making the Rockwell hardness test taken by every 1.6 mm. That means 1 by 16 inches along the length from the punch end. So from starting of this quenched end, we are making the Rockwell hardness numbers. So we may identify that quenched end, if in the quenched end that we are getting the hardness number is too high rather than the normal end is not having that much of hardness value. So from this Germany end quench test, we may able to identify that how much quenching rate to be maintained. If we are maintaining with the help of a standard jet of 25 degrees centigrade, then what kind of a roughness hardness value will be obtained. So based on this value, we may able to control this rate as well as we may able to take the specimen what we are required. So this is one kind of a Germany end-quench test. It is universally accepted. Based on this test only, we are making the hardness materials and we are selecting the punching medium in most of the engineering applications. Thank you.